approximately for each of these events, and then we're going to go to the schoolhouse for a pint afterwards, so everyone's welcome to join. So I suppose given that we're fairly time constrained, we'll just hand over to Martin. Martin is a developer program manager in Google, who's kindly flown in from Mountain View, just arrived in Dublin this morning. He's going to give a talk on the Google and prediction storage API. So over to you, Martin. No, you don't need this, I guess.
Let's see if this one works. Yep. All right. All right. Hello, everybody. I can't hear you. No, I won't do any of that. Thanks for coming tonight. We're going to talk about bulletproofing your storage and predicting the future. My name is Martin Omander. I grew up and went to school in Sweden and moved to Silicon Valley about 11 years ago. And I've worked at Google for the last 5 years on a couple of different teams. Now I'm working in developer relations and building out documentation for new APIs as they come along, and talk to people outside Google like yourselves about new APIs. I would like to ask you, if you don't mind, some questions. I would like you to introduce yourselves a little bit, so I know that I'm saying things that are relevant to you guys. You see at the top here we have 4 bullet points: working for a big company, small company, a startup, or if you're a teacher or student or hobbyist. Take a couple of seconds to think about which of these 4 groups above the line you would belong to. In a minute I will ask you to raise some hands here. Okay, have you all figured out who you work for? How many of you work for big companies, more than 100 employees? I do. Okay. Okay, thank you. How many of you work for small companies that are not startup, but regular small companies? Okay, a couple more, thank you. Startups, companies that, okay, very good, thank you. Student or teachers or hobbyists? Ooh, quite a bit. Great. Exciting. Finally, how many of you have used the Google Storage API before? I have. Okay, 1, 2, 3, 4, 5, 6. Okay. How many of you have used someone else's storage services, like Amazon S3, or built a service? Ooh, quite a bit. Wow. Thank you. Exciting. Prediction. How many of you used Google Prediction API? I have. Am I the only one? All right. I guess it makes sense I'm up here then. And how many of you have used or built out prediction or machine learning stuff elsewhere? Yeah. Thank you. All right, great. Well, oh, I almost forgot. I want to take a picture of you guys to show to the folks back home. If you don't want to be in the picture, look away. If you do want to be in the picture, it'd be great if you can wave. And you will wave to my boss back home in California. And I can say, look, what a cool place this is. And please send me to Dublin more times. So wave, yes, more, smile. Woohoo, yes. There we go. Yes, very good. Thank you. You could have waved a little more next time. Yeah, okay, next time. Next time. All right. With those preliminaries out of the way, let's talk about the Keck Observatory in Hawaii. The Keck Observatory in Mauna Kea, Hawaii, is the largest or the second largest terrestrial telescope in the world. It has adaptive optics, so it can compensate for distortions made by the atmosphere. It's up at above 4,000 meters elevation, so it's above 90% of the humidity in the air. It's very clean air up there. It weighs a lot. There are 2 of these huge telescopes that can work separately or simulate an even larger mirror together. And it can detect the IR, infrared piece of this telescope, can detect the equivalent of a candle flame on the surface of the moon and detect very faint stuff. And these cost $140 million to build. And they have an excellent track record that these guys found more extrasolar planets than any other telescope. And they've found direct evidence of Big Bang, and the list goes on and on about cool science that people have done on these telescopes. So when I read about these, my first thought was, I want one of these in my backyard. But then I started thinking, I looked at the layout, and this is way bigger than my backyard. Also, I don't have a staff of people who can keep it tuned and update the software on it and swap out parts as they break. And I probably wouldn't use it a whole lot of the time. I would use it very, very seldom. When you have some friends over, you get drunk and you want to go out and stargaze or something. But it probably would be a big waste of resources for me to pay $140 million to have this in my backyard. So if there's one thing that I'd like you to remember as you leave from here, it is that not everyone can own a Keck observatory, but not everyone has to. As a matter of fact, the Keck observatory can be controlled remotely, either from a station down at sea level on Hawaii, so you don't have to go up and be oxygen starved and be up there in the cold. You can be down at the comfortable tropical climate of Hawaii, or you can be anywhere else in the world where you have an Ethernet plug, and you can control this thing. And a couple of days ago, I actually went in and looked at the schedule. There were, in July, this year, there were 27 different teams using this magnificent piece of equipment. There was only one team at one university who built it, but 27 other teams are using it. And why are we talking about all this? Well, it turns out... So you should focus at what you are good at. You know your customers. You know your use cases. You know what you're looking for, if you're looking for the Big Bang or you're looking for extrasolar planets or whatever it is. Most of you aren't expert telescope makers. You should use someone else's telescope. Stand on someone else's shoulders. Don't build your own telescope unless you're better than everyone else at building telescopes. And tonight, I'm going to show off 2 telescopes that Google built. One is for storing data, and one is for predicting the future. Now, we use these telescopes every day at Google. We have to use this sort of technology to power Google Search and Gmail and so on. We invite you to come in and use them as well. And we think that if you come in and use them, you'll discover that you'll have more time to spend on talking to your customers, figuring out what you are good at, figuring out what use cases you want to support, figuring out what black holes or extrasolar planets you want to look at. Stuff that we at Google haven't even thought about looking for. As we go through, I'm going to show off a couple of demos and give some specifics about products. As I'm doing so, feel free to interrupt at any point with questions. We'll also have 5 or 10 questions at the end. Okay, let's start talking about Google Storage API. And rather than talk about it, I'm actually going to show you. Let's see here. Okay. In the beginning, there was the command prompt. So this is a normal Mac laptop. I can do things like ls to get a list of my files, and pwd to get what directory I'm in. Once you go in and set up a Google Storage account, you get this handy little utility called gsutil, Google Storage Util, that allow you to run similar commands, but on your little sliver of the Google Cloud. So here's gsutil ls. I have one directory in Google's Cloud called Omander predict. Now I can do things like gsutil. It's not called make directory. It's called make bucket, MB. I can say I'm going to make a directory up on Google servers that only I can use. The L location allows me to set where in the world I want this to be. I want this to be in Europe because I'm here now and most of my users are here. And then I want the directory to be called Omander pics, for example. So just like I could create a directory on my local machine, I can create one up on Google's cloud. Now I have 2 directories up there. And just like normal directory, I can copy files. Oh, right, so here's my image directory. I have a couple of image files here. Now I want those to go up into Google's cloud so that they can be served and shown to others, not just myself. So there's a copy command, copy star to Omander pics. And now it's kind of like copying between 2 local hard drives, except that one hard drive is the sum of Google's data centers in Europe, because that's what I chose here. Google now takes care, it looks like a simple copy command from our point of view, but Google takes care of all the load balancing and making sure the hard drives work and swapping out dead drives and sending the data to the right data center in Europe so it's close to your users as Google learns from where your users are accessing this. Let's see, there was one file there called Keck Observatory. I don't know if you saw. Now it's access denied here when I try to hit that file because by default, when I upload something, when I use the Google Cloud, Google Storage in the Google Cloud, it's private only to me and to whoever I explicitly share it with. So let's say we want to serve these images off of Google's Cloud instead of from my own application server. And then I can say gsutil set access control list and say public should be allowed to read, and let's say Omander pics, and I want to make all the files in the pics directory public readable. There, done that. Now this is served from Google's cloud. Some data center, we're in Dublin right now, so it's probably served from a data center around here somewhere. As users access this from elsewhere in Europe, Google just makes sure it all works in the background. Let's see. I'm going to show as well, download is simple too. You can copy the other way as well. So I just created a new directory called pics. On my local machine, it has nothing in it. You saw ls returned nothing. So I can do a copy the other way, where I say copy gs Omander pics, and I just say to local file. And I'm pulling down back my files from the Google Cloud again to my local hard drive. And just to prove that I did, here are the files. As a matter of fact, who here has heard about the Data Liberation Front, Google's Data Liberation Front? A couple. Okay, great. Thank you. Great. There is this, at Google, we don't want to keep your data hostage. It should be very easy to swap between different services. We want to be the best service, of course, and we'd be really happy if you use us. But you should use us because you like us, not because you're locked in. So you can actually, with gsutil, do something like gsutil. I could make a bucket on Amazon's S3. Now I've created a directory on Amazon's cloud. Now I can say copy all my files, this is the escape hatch you're seeing right here. We hope you'll never use it, but it's good to have an escape hatch. If you end up hating Google Storage, you just want to take all your stuff off there and move it to Amazon. This is what you do. Of course, we hope you do it the other way around, but there. So now it's a copy operation from my directory in Google's cloud to Amazon's cloud. And there they're all copied over. Now, when that's all done, I can shut down my Google Storage account if I want to use Amazon instead. This is an important part of our philosophy. You should always be free to leave. And actually, let's prove that it worked. So we do ls on my S3 account, and there it all is on Amazon's cloud. All right. So a couple of closing comments on storage. This allows you to use the power of Google's data centers. Because we are serving lots and lots of YouTube videos and images and emails and search results and all that stuff. And folks like John over here and Gene, who ran off because I believe he ran off. Okay, yep. There are a bunch of people here at Google who are on pager duty and who make sure that systems work. And if you use our APIs, you will not have to carry pagers, because we do. We must anyway, because we serve all our own data on this stuff. So we invite you to use our stuff. Also, quite often when you serve a lot of data, you end up putting it on an outsourced data service somewhere, and then building a content delivery network around it, a CDN around it. And that allows you, the CDN allows you to serve quickly to the rest of the world. But so you have to have two vendors you talk to, basically. The content, where you store the content, and then the content delivery network. With Google, you get both in one. We copy it between the data centers. We figure out where it needs to go, so you don't have to have two relationships with two different vendors. You just do a CP command like I did, and you're up and running. So you can use this as an extra hard drive and do things like I did here. But our documentation is really set up for 5 use cases, and our API is really optimized around these 5 use cases. The first one is storage for applications. So, for example, if you build a photo editing service online, then you can have your clients, you build the browser app that lets people edit photos, upload photos, and then you can store your users' photos, the application data, on Google's backend. Another is sharing. If you need to share a lot of data, well, first off, if you need to share a lot of text or a lot of spreadsheet data, Google Docs is a great place to do that. But if you need to share other data that's not structured or binary or something like that in a team, you can have a file server in your building where you do that, but it gets tricky as soon as you need to share with people in other companies or other organizations. With Google Storage, that sharing use case works really well. This storage is also used for computation, and we'll show in about 15 minutes, we'll talk about how to use Google Storage for the prediction API. You can use it for static content hosting, like the images I uploaded, or MP3 files or video clips or what have you. And finally, backup and recovery. That's a use case I've actually seen a couple of commercial products now have launched, where they use Google Storage as the backend. There's one that you can back up your BlackBerry, I think, and they take care of. They wrote the BlackBerry app. That's what they're good at, and then they just keep the bits and bytes over in our cloud to make sure they're always available. Actually, in my last job, I built something like the first use case storage for applications. And who here has built this big storage network where you need to store more data than can fit on one computer, and you need to make it accessible and so on. Nobody? Yeah, there, yes. And was there somebody back there as well? No? Ah, okay, Gene, good. It's hard. So, or first of all, do you agree that it was hard? Maybe you find it easy. It's not easy. What? It'll be interesting to compare, actually, my old job and your. What did you find the hardest? Conflicting requirements. Oh, yep. I saw that too, yeah. I worked at a company where you could upload pictures and get them custom printed on a T-shirt or coffee mug or mouse pad, that sort of thing. And we got 5,000 images a day, and back then, this was many years ago. And it was hard to set this up and store millions of images and make sure they're all in the right place and make sure you can find them and you make sure they're all backed up. If you have millions of files and you need to back them up somewhere, then you have to have millions of files times 2 or times 3 to make it all work. It's hard stuff. It's best to let someone else deal with that. How can you access this? Okay, so there are a couple of different ways you can hit this API. You can come in at the REST API level. This is where you would do gets or post or put in with HTTP at the really low level if you want to be close to the metal. Then there are client libraries like the Boto. If you are into Python, then we have the Boto library. Java uses the Jetset library. There's a Google Storage library for .NET. Boto and Jetset, by the way, they work for both, for Amazon and for Google, and a bunch of other vendors as well. So they're rapidly becoming sort of standard. There is a command line tool, gsutil, that you just saw me use. And finally, there is a web UI built on top of it as well that we built. It's pretty primitive. I'm sure you can build better ones with the API, but we provide that as a sort of default. Sometimes it's easier to use that than the command line tool. And finally, let's see. Oh, right. How to get started on this. So you should try this out because there's a free trial that you can get into right now. But here, I'm just going to show you. I'm going to reload this. So this is the Google API console. And here you can define new projects. Like I defined a project called API project. And then in here, I can define who I want to share this with. And once I've defined a project, I can turn on things like Google Storage is turned on. I can turn that off, for example. Turn it back on. And then, there we go, Google Storage back on. And then in here, I can see all the details on how to get to my data and all the keys and all that good stuff. But this was really built because often it's not just you using the APIs. And this way, you can go in here and give access to coworkers or people in other organizations and work on the same project. And everybody can have access to the same stuff. What programming languages do you guys work in, by the way? That'd be interesting. Java? Who's primarily Java? Okay, a little more than half. Python? Okay. I haven't programmed a line in any other language but Python since I learned Python, by the way. Life is too short for curly brackets and things. What about .NET? Primary in .NET? Oh, couple. Okay. So over there. Did I miss any languages? Who did I miss? Ruby. Oh, of course. Ruby. Yeah. Sergio. Anybody else? Ruby? No. Oh, over there. Yeah. Oh, back there as well. I'm pretty sure there are Ruby libraries for this as well, but I haven't actually played with them because I don't know Ruby. The worst that can happen, so I do interviews for Google sometimes, and then I ask candidates to come in and write code, and it always becomes very embarrassing when they say, well, I want to write it in Ruby, and I have to pretend I understand the code they write. So finally, you should get started on this right away. There's no reason not to. So when you get home tonight, sign up for the free trial. It runs for the rest of the year. You get 5 gigabytes for free. You can play with all the tools we've seen and the APIs and all that. See if it works for you. Then there's a pricing that kicks in if you use up more than the free trial or if you want to stay on after December 31st. And finally, I wanted to throw in a very nice quote from our friends at Cloud Harmony. It's a cloud service company where they say that this is a hybrid model. They say you get the performance of a content delivery network, but you get the durability and consistency and access control of an enterprise storage solution. Putting them together is an exciting leap forward. Very nice of them to say that. All right, that's about it for Google Storage. Any questions on Google Storage before we try to predict the future?
Are there any Dropbox-like clients yet, Martin?
No, there aren't any Dropbox. So the question was, are there Dropbox-like clients? There aren't yet, but I'm sure there are at least 10 of them being written as we speak.
and that pricing there is 17 cents per gig per month. You don't get anything for free. You're paying per gigabyte.
Yep, that's right. Outside of the free trial, then you pay for the first. Yep. So. Exactly. January 1st onwards, you pay for everything. Yep. Yeah. That's correct. All right. Yeah. Right. So what about locking? And yeah, the way it works is when you write a file, then nobody else can access it. But at the time, as soon as you're done writing it, anybody who accesses it right after that are guaranteed to get the new version. So there's no propagation or having to wait or anything for that. No matter where the file is stored, we guarantee that users always get the latest version. But it is locked, I believe, when you're writing it. Does that answer your question?
Not really. When you replicate a file to the US, and I start writing in Europe, and I have thousands of accesses getting that file at the same time from all your different data centers where your CDN-like quality replicates it, what versions of files do they get, and how do I make sure everyone gets the latest version? And what if I have two things that update the same file simultaneously in two different data centers at opposite sides of the planet?
Interesting. Multiple updates and locking, yeah. I actually don't know. All I know is that when you finished writing, you're guaranteed that anybody who hits it afterwards is guaranteed to get the latest version. All right. Any other questions before we dive into predicting? All right. Yeah.
How is the namespace structured?
Oh yeah, namespace. How is the namespace structured? This is much like Amazon S3. It's a global namespace. So you remember it was called buckets and not directories. So buckets behave they're kind of sort of like directories, except there is a global namespace. That's why I call my Omander picks, because if I just call it picks, somebody else would have picked it. All right, let's talk about prediction. Let's talk about language detection first. So this is a problem, detecting language in random text you get. This is a problem that we face at Google all the time. Let's see here. So there are 3 steps to the prediction API. It's pretty simple, really. It's first you upload your data, your training data. Then you train Google on that training data, and then you make your predictions. So first you need to upload your data. So there is a sample file here. As you start playing with the prediction API, you will find a bunch of samples. And here is a file that it's a comma-separated file with only 2 columns. One has the language. Let's see. There we go. So this line 75 is French. And then there is a sentence in French in the second column. And it says Spanish here, and there's a sentence in Spanish. And then there are a bunch of English and so on. So this is the training data. In the first column, you should always put the result. And then in column 2 and onwards, you put the inputs. So in this way, you're telling Google that, oh, so Bill got to come down, etc., etc. You're telling Google this is English. And when you see text that's similar to this, oh, so Bill got to come down, then the result should be English. So 3 steps. Does anybody remember what the first step was? Somebody? I'm sorry? Upload, yes, thank you. Upload is the first step. Thank you. Great. And we now have this handy dandy little utility called gsutil. So let's use that. We'll copy this. Oh, let's see. Here we go, language file. So we use gsutil to copy the language file up to my directory in the cloud, or my bucket in the cloud. Okay, great. First step done. That was the upload. Does anybody remember the second step? Train. Yes, thank you. Very good. So now the training data is there, but Google doesn't know it's training data. We need to tell Google, train on this. So I have a little shell script here that just does a post up to Google with the right authentication. So I say train on Omander predict, and on the file language id.txt. Okay, Google's thinking about it. Can I access the file? Okay, then we get a piece of JSON back. Who here has worked with JSON? Does this look familiar? Oh, almost everybody. Cool. So this is basically structured data. And it just says that this is a response of type prediction training. So Google is basically saying, yes, we understood. I'm started training. Then this is asynchronous, by the way. So we don't know if the training is done. So we can do a check training to make sure it's done. We'll see if Google finished yet, or if it's still chugging along. Okay, so here's a prediction training, blah, 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 lots of IDs and things. But the important thing is training status is done. All right, we did upload. We did training. What was the third step? Anybody? What's that? Test, predict, yes, yep, that's right. So now we can say things like, I'll call another little shell script that just does a post of some JSON. So I'll say predict, and which model should we use? Well, we'll use the language id.txt. That is the model name. That was the file name. Now it's the model name. And then we can say, for example, to be or not to be. That is the question. And now we can see if Google can figure this one out. Internal error. Very nice. Yes, that's right. Auth predict. Let's have a look if we did it right here. Yeah. Internal error. Oh, yeah. Okay, user error. Replace user and try again. Thank you. There we go. Yes, this was not a good error message. All right. Should we see? Anybody? What are the odds you think it'll work? We'll see. All right. So here, a little longer response came back. It was a prediction output response. And then the output label was, so the short story was, this is English. If you're interested in digging deeper, you can see that it said 0.1, that it was French, 17% chance it was Spanish, and pretty overwhelmingly it analyzed that this was English. So what we did here was do categorization. This is when you have something, for example, a Twitter message or Google Plus message, and you want to analyze what language it was. Which category does it fit into? English, French, or Spanish? Or an email. Does this fit into a real email that a real person would write? Or is it a spam message? Or this is a short message on Google Plus. Is this a positive or a negative message? What's the sentiment? Is it this person who's writing about my product, is he writing that he likes it or that he hates it? Or maybe that it's neutral. He's just saying he's using it. That is categorization. And for that, you just tell Google a bunch of categories, a bunch of examples for each category, like we saw in this file, and you're off. And Google can, you're off to the races, and Google can start categorizing for you. So we filter spam and detect languages, and we do all that stuff all the time ourselves. So we use this all the time. And we thought it might be useful to others as well, and that's why we're opening it up. Again, this is all based on a REST API, and then there are client libraries on top of that for a bunch of different languages. And then there is an API Explorer on top of that, where you can call a bunch of different Google APIs with the API Explorer, and you can play with that if you want to, and see what other cool APIs there are that you can use that are JSON-based. Upload, train, predict. Okay, so we did categorization. There is another type of machine learning that's where you don't output a category like we did with the languages, but you output a number, a scalar value. So let's see, we have a little time. Yeah, let's run a little demo on that one. This is real estate. So I bought a house right at the height of the bubble in Silicon Valley. So I'm very interested in real estate prices in Silicon Valley. And I'm generally dismayed whenever I see what my neighbors who are foreclosing on their houses and what their houses are going for. So I went out and a couple of days ago, I pulled some data on houses sold in my neighborhood. And I pulled this from a real estate website. So this is the Rex Manor neighborhood of Mountain View. And again, remember the first column up here should be the result. So I put the price in there. So this first house was sold for $565,000. And then these are the inputs that yielded that price. So this house was 3 bedrooms, 1 bathroom, 860 square feet. It was built in 1950, and it is a house, a single-family residency. So these are all houses, real houses that were actually sold over the last 2 years in the Rex Manor neighborhood. And then as we go down the list, there were some condos sold as well, because it turns out that the type of house matters a lot, and we'll see that in the data later on. And then a bunch of them were townhouses as well. So let's upload this and see what Google says about the value of my house. Jeez. So again, what was the first step of prediction? Upload, yes, very good. So send the data up there. Okay, done. The data now sits on Google servers. Then we'll tell Google to train on it. Yes. Yeah, not forget predict this time. I won't have another of those errors. Okay, it's training. So Google confirms that it started training. Let's see if it's done. So we check the training result. Is Google done, or do we need to wait a little bit? Ah, training status done. Okay, we can start asking it questions. So let's run a prediction. We'll use the Omander predict / houses. So this model. Oh, thank you. Wouldn't want to see another 500 error. No, thanks. Okay, so we can, for example, say a 2-bedroom house with 1 bathroom and 880 square feet. This is actually what the houses in my neighborhood were when they were first built in 1950. This is what they looked like. 2 bedrooms, 1 bathroom, 880 square feet, built in 1950. Now, given all the data we fed into Google, it will now make a prediction on the value of this house if we were to put this on the market. Oh, sorry. We need to add that it's a house. It's worth negative $500,000. Okay. Not good. There we go. We need to actually say that it's a house. Okay, and there it comes out. Google claims it's, according to the data we fed in, this is worth something like $580,000. Now let's say this house owner is thinking about whether to add another bathroom to his house, a bedroom and bathroom, and want to know if it's worth it. So that will be something like, we add a few square yards here, square feet, 3. Now we have 3 bedrooms, 2 bathrooms, 1,280 square feet. It's still built in 1950. It's still a house, so we leave those as is. And now it came out to 686,000. So this homeowner now knows that as long as the expanding my house costs less than $100,000, I will make money on this investment. You can also do things like see, what if it were a condo instead? Remember, it was 686,000 if it were a house, but it's only $453,000 if it's a condo. Condos go for less because you share walls and because you often pay a homeowner association fee and things like that. All right. So it's built, again, you can use a bunch of use cases, and the real estate use case is probably a little frivolous. I should probably have used more data. But these are the main use cases that is built for. Basically, different types of classification and sentiment analysis. There are demos for all of this up on the website, so you can go in and actually run code for these. Product recommendation is a really interesting demo as well, where it tries to predict to see if what people have bought before and what they will buy next and what to show them on a website. Then finally, a little plug for Ralph Waldo Emerson, essayist from the 1840s in the US. He had a lot of good things to say, but this is what he said about the prediction API. He said that he said that our best thoughts come from others. And I think that is absolutely true. So here are a couple of new features in the prediction API that leverage others. For example, the top one there is hosted models. There are now models that Google have put up, like a sentiment model. So you don't have to load your own sentiment data. You can just use Google's model. So you can skip the first 2 steps, upload and train. You can just start predicting. As a matter of fact, you can, if you're into machine learning at all, or if you're sitting on a good treasure trove of data, you can upload it and build your own model and share that model with others and share revenue with Google on that. All the details are on the website. So Also, if you're into machine learning, you may recognize PMML. This is an XML standard for models. You recognize it? Okay, good. I got the abbreviation right. Thank you. So you can import your own model if you have one already that you built in another tool. And finally, just 2 months ago, the streaming updates became available. And this allows you to use data in real time and update your model. So for example, if you have coworkers or your users of your system actually feed data to you and say that this was a positive tweet, or that real estate value is off, or this really looks, you thought it wasn't spam, but I know it is spam. You can put that data back into the model. So the model gets better and better over time. Again, there is no reason not to start with this. Tonight, when you get home from here, you should log in, and there's a free quota. You get 100 predictions per day. So, it expires 6 months after you set up the project, and then you can pay if you go on after that $10 a month, and that gives you 10,000 predictions a month, and then you can buy more on top of that. So, again, back to this. These are two really nice pieces of equipment, and I'd hate to see you guys go off and not think about your use cases and not look for your extrasolar planets and not think about your black holes because you're stuck building a telescope. We built a telescope. We built 2 great telescopes that you can use. And you have lots of great use cases. You probably will use these telescopes for things we didn't even think about when we built them. But that's what's cool about technology and about the internet and us working together. And with that, I'd like to thank you for your time, and there'll be time for a couple of questions. Yep. Yeah. Do we support other content types for the prediction API? No, it's what we saw here. So it's numbers can be inputs and text can be input. And then you have to, if you have anything else, you need to transform it to one of those.
So prediction is easy, Martin. Accurate prediction.
Especially about the future.
Can you say anything about obviously it's something about how long a piece of string question, but comment on
Pardon, how long?
Can you comment, obviously a general question like how accurate is it?
How accurate is it? Yeah. So I've seen a lot of people use it and not get accurate results because the biggest mistake people do is not supply enough training data, and you're working on machine learning, you know how dangerous that can be. So there is a guideline that there should be, for every column you have in that comma-separated file you upload, you should have several dozen rows of data. So let's say you have 4 columns, then you should have a couple of hundred rows of data, and then you can get pretty accurate. But if you don't upload enough, then you don't get so accurate. Yeah. Does this, okay, so what other features does this, yep, so right, bunch of other features. What other features than those we saw here does the prediction API support?
Because just to follow up on the accuracy question, if I had a client that I got the one accuracy measure there, they shoot me if I could present that as a hard measure. They laugh me out of the room.
Ah, right. So how accurate are the models? How can we know? Yep. Can I get other? Can I get a very good accuracy measure off the single figure? The single figure that's here. This is what you get now. Yeah. If you are looking for other things, though, I know that the team is actively working on this, and this is something that was just released came out in general availability just 2 months ago. So I know that they're soliciting feedback right now, and if you get on the forum, on the Prediction API forum, there's a forum link on there, and they would love to hear what of those things you mentioned are most useful.
Just on the other product suites, so how does it link in with the likes of Refine, which is obviously the precursor in most common data sets because they're dirty?
How does it link in with Refine because the data is dirty? Yeah. It doesn't link in very much right now. We're getting there, but this is pretty new out of the gate. Yeah. But get on the forum, and there are lots of good discussions with people who really understand this problem space. And as we understand what people actually will use, then we make sure that those things are built. All right.
So I think we'd thank Martin in the usual manner. I think it was an excellent talk.
Thank you.
So this is an experiment. We've had a good reaction to it so far. So hopefully, I think there's a good few people in the audience here who are quite interested in this topic. Certainly, the panel are very engaged and interested in this topic. So we're delighted to have Bill Lau here, who's going to chair the discussion on hackerspaces and formal education. Bill, as I've introduced him over email, has very many strings to his bow. He's had significant success in business, in particular with Zing, but he had a couple of other businesses before that, and he's actively involved in philanthropy, and he's operating at the moment as a venture capitalist with SOS Ventures. So Bill is going to say a few words, I think, about the topic, and then the guys in the panel are going to set out their stalls. So over to you, Bill.
Thanks very much. Can everyone hear me? Yes. Excellent. So, hackerspaces and formal education, chalk and cheese or hand and glove. Before I go any further, I just want to mention the word education. Education could have two potential Latin roots. One, educo, and the other, educat. Educat is about leading someone somewhere. If you look up the definition. Educo is about drawing forth something from someone. Now, the way we do education, I would put to you, is definitely educat. But I would also love it if you would consider the possibilities of educo. How you draw forth something within someone as a form of learning. So I'm going to frame the discussion very briefly, have some definitions, hopefully seed the discussion, and see if there are some issues, and also are there any answers. And I might say it's always intimidating to talk to a room that has an average IQ way above my own, so please excuse slides, content, etc. So firstly, hackerspace. Now, hackerspaces are generally very community-based, open. They don't tend to have an agenda. They can actually almost be anarchic. They tend to be very progressive. Hopefully, they're self-financing. They tend to hold themselves apart from mainstream education. Although there are some notable, powerful hackerspaces attached to MIT and to Stanford. The history of the hackerspace is complex, dynamic, growing. It's organic. I think there is a certain amount of fun in a hackerspace that is not up there, but I think that's a key point. And hackerspaces or hackspaces are more often hardware, in my view, than software. I think you do get both, but there is a lot of actual physical tinkering going on in most of the hackspaces I've seen. There's coding, but there's more get your soldering iron out, or get your Sugru out, or get your stuff. In Ireland, there are a few. I actually haven't done any research on them. Sean put together this slide. Apparently one in Galway closed. What do you know, Sean, about these three hackspaces?
Perfectly frank,
Use the
Bill,
mic.
I don't know. I don't know. Mic. Hello?
You don't know anything about them?
Some of the panel do know. But
Okay, so any of the panelists able to give us 3 words on any of these?
Well, there's a few of them in the audience. Who's here? This 091 down the back.
Okay, excellent. Good. Well, we'll hear from you later then about these particular hackerspaces because it's too early for audience involvement. Give me a minute. Formal education. How many people here actually have a formal degree? Excellent. Keep your hand up if you use what you learned every day. Keep your hand up if you couldn't have learned what you learned anywhere else. Right. Formal education technology. One of the things that astounds me is at early age groups, there's little formal computer education. And what there is Word, Excel, PowerPoint, which is, to me, is not particularly useful to learn as a young kid. I have always considered coding to be a form of literacy. And every piece of brain science that we have tells us that the brain goes through changes and phases of its ability to assimilate new data, particularly language data, particularly syntactic data. And between the ages of 6 and 16, it is particularly good at taking on new languages, new syntax, and new concepts. So the idea that we don't teach coding, which for me is modern literacy for the internet age, until college is frankly crazy. And it's a thing that occurs all over the world. And to me, that's madness. I think that even somebody who's destined to be a lawyer or a doctor, if they have the ability to speak and think in a modern coding language, even if they have to update that knowledge every now and again, is still has a skill far and above somebody who doesn't. Similarly, a doctor who speaks French as well as English has an advantage over a doctor who only speaks English. When you look at second level and third level education, third level you get more variety of courses, but by that time I think it's a little too late often. And a lot of the courses are stale. I saw into a computer lab recently, I won't say where, but on the wall was a waterfall diagram. Now, frankly, anyone who's being taught to use a waterfall diagram in an agile world is pretty much screwed as far as I'm concerned. Anyone agree? Yeah? No? But that's what's being taught. But that's where I come back to that point of educat. Leadership, if you're going to lead, you should be, in my view, creating a future that wasn't going to happen anyway. It's very hard to do that, to create other than a default future, if you're leading from a technology base that's stale. So, here are some issues. Hackerspaces tend to attract motivated and talented people. And they tend to work collaboratively. And that is really not classically part of the education system, in my view. It says it is there, but I don't see the collaborative part in the education system. Hackspace people have characteristics demanded by employers. I think that's totally true. One of the very, very interesting things that I'd like you to look at is Sugata Mitra's TED Talk on his experiments in educating without teachers, where he has found that if you give kids a computer and a little bit of time and you let them collaborate around the computer, they can learn very advanced material without any other formal structure other than the computer and themselves collaborating. But he found something even more fascinating. If you encourage them, they learn twice as effectively. And so he set up what I think is one of the most amazing experiments. He used Skype to set up these little collaborative workspaces for kids to learn in front of computers. And then he hired English grandmothers to Skype into their workspaces and offer them nothing but encouragement. He called it the Granny Cloud. And it worked spectacularly well. So, Hackspace people, what do they like? What motivates them? That's one thing. And given that there is real education and learning Do you want to dovetail the Hackerspaces with the formal education system? I mean, if you did that, would it be a public service to the education system? Would the education system's natural immune system of bureaucracy reject it? Would it destroy the Hackerspaces, or would the Hackerspaces take over because they're just better? I don't know. But I'm going to throw that question to the panel after I get them to do two things. I want them to introduce themselves one after the other, very short introduction, and say what dog you have in this fight. So, starting with...
Good evening. My name is John Looney. I have been working here in Google Ireland for about 6 years. Spent 5 years of that looking after the cloud and the infrastructure and the storage stuff you saw earlier on. For the last year, though, I've been running a graduate program training system administrators. Basically, Google has a real problem finding the people with the specific skill set we need. So we're taking junior engineers, guys with masters and bachelor's degrees in science, maybe this worked in tech stop or hardware operations, data center type work for a few years. And in a year with 5 months of training, full-time lectures, and 7 months of internship, we basically hire them in then as full-time site reliability engineers, the guys carrying the pager for google.com. That's not something you can do with a degree, and in fact we found that the kind of stuff that people come out with degrees, it's not so much, but we can talk about that later. I definitely am on the side of Hackerspaces in this. I kind of started one about 15 years ago in DCU around Unix and eventually the Irish Linux user group, which was kind of like a hackerspace for the first 5 years where we were teaching each other how to use it.
Hi, my name is James Welton. I have a startup in the social media monitoring and analytical space. I founded Coder Dojo with Bill, which is free coding clubs targeted at kids. I finished my Leaving Cert a few weeks ago, and I'm primarily on the side of Hackerspaces, simply because there's no support for development languages in schools. I can see 1, 2, 3, 4, 5 incredible developers in front of me. All have either just done their Leaving Cert or haven't even gotten there, and I don't think school has given them any support in that.
How's it going? I'm Mark. I'm going into third year in DIT, so haven't got a degree yet. I'm actually part of TOG, the Hackerspace in Dublin. I have to say there's not really a whole lot that I can kind of say on, like I haven't really started a company, I haven't really, done anything incredible, but I'm definitely on the side of Hackerspaces. It's definitely been always kind of an area that I can learn, I can progress, and a lot of the knowledge that I've gotten is, from the Hackerspace or kind of working my own. Sorry.
My name's Martin Mitchell. I'm currently a software engineer with IBM. I've been through the 4 years of education in college, and I've been a member of TOG since it first started in January 2009, when it was just 14 people meeting up and we had no space. And then 6 months later, we actually got together and we actually got a space and built TOG. So I'm definitely on the side for Hackerspaces.
How do I follow that? My name is Mark Deegan. I'm a lecturer at Dublin Institute of Technology, where I've attempted to lecture and to instill some knowledge in students for the past 20 years, including Mark here. I'd like to wish him the best of luck in any remaining exams he has in the DIT. I'm not going to take a side on this, but...
but I've got a chair for you right here.
I feel safer over there. But I will give a brief anecdote of my background. I've a degree in engineering. I was a classmate of Brian Farrell's. There's every chance that either Brian Farrell studied or didn't study my notes when he was in college, because mine did the rounds because they were the best ones that were there. Quite likely did. I may even have given him grinds. I know I gave grinds to my classmates, but many of them did better than me in their finals than I did. I could understand the stuff, I could communicate it, but I couldn't sit exams, and that has instilled in me a lifelong belief that the ability to sit exams and the abilities to do something with the information you have stuck in your head are two entirely different facts. Formal education tends to forget that fact, and particularly in Ireland. James here mentioned students who had done their Leaving Cert in Ireland. I pity you. And I also pity undergraduates who are going through their 4-year traffic lights at formal education in Ireland, which is, I think, where this discussion started with Sean a couple of months ago. I believe that the 4-year degree programs in Ireland are 4-year traffic lights, where we hold the student in abeyance unless he or she does something ridiculous to get chucked out of college. We give them a degree and off they go, and we think they're qualified for something. I once gained access to the financial services system at the DIT and put myself in a position of being able to print checks. I didn't profit financially from the discovery. I brought it to the attention of the authorities, and the reaction was, as I said earlier on, the reaction was to change the IP address of the financial services machine. Before you all laughed, is there anybody in the room who thinks that has any chance of... No. 6 months later, the back doors were still there in the system and we gave up. And by the way, the system administrator is now one of the most senior IS people in the DIT, nearly 20 years on. So organizations such as third level institutions don't change, certainly don't change rapidly. But I'm not going to be the kicking dog or the whipping boy for upstarts here to the right of me. So I'm going to do my best to defend formal education. Thank you.
Oh, good luck.
I did say I was on the side of Hackerspaces, but one of the things I learned when I started in Google was that there were a bunch of people who had been through the formal education system, and I was in complete awe of them. 2 guys were talking about the degree they had from Waterloo in Canada. In 3rd year, one of the projects, they were given 10 object files, compiled binaries, and they were told, here's the API, go write an operating system that can run all 10 programs. And I was looking at the guys going, oh, that would have been the most amazing project ever. And they said, oh, it was really hard, like half the class failed. They only ran 5 or 6 of the binaries. And I was going, oh my God, what kind of binaries? One of them included a graphical program where you had to move a mouse. And that just blew me away that 3rd years would be able to do that. And they were expected to or told you'll fail if you don't. So formal education can be done wonderfully, and you don't need a hackerspace to make someone that good. It's just a shame not every university is as good as University in Waterloo.
Hey, keep the mic. I don't know. So let me see. Where's a good place to start? John, if you were to look at the social good of a hackerspace, do you think there would be more social good in keeping that movement separate, or more social good from actually integrating it with formal education?
Does integration mean it can't exist outside? I'm thinking there are a few ways of answering that. One would be that every university would have a hackerspace, a workshop where people can work on any kind of craziness, sofas that they can sit down on crochet or write out, electrical schematics and talk to people. If it's only done in universities, I think it would be kind of harmful because you tend to get just younger people. And I think one of the massive values of hackerspaces is that you get random people from around the community. I've been in a few of the hackerspaces, and I was just amazed to see you've got electrical engineers in their 50s who have, remember building arcade machines 30 years ago, and you've got new guys who are, fit satellite dishes at Sky, have never went to college, but have taught themselves how to restore said arcade machines, and the two can get together and have fun. I don't think that can happen in a university. So I wouldn't like to see it just in universities, but I would believe that every university should have one.
James.
It was a long drive.
What age do you think it's appropriate to get people into a hackspace?
Shane, can you put up your hand? Shane did his first Linux install age 6. We had some guy contact us.
Sorry, just say that again slowly.
First Linux install age 6.
About that, yes, thank you. That's more the reaction I was thinking of. Yeah. Keep going.
Really, I think it's whatever age interest is presented at, but the biggest problem is exposure to this. Earlier on in the year, I won just a prize for web design. I was called over the school intercom, whatever. But students came up to me, and the social network just came out, and it was at the peak of its popularity. And they said, "Okay, so where do I go to learn how to make Facebook or something?" As silly question that is. But sorry, yeah, that's the first year asked me that. But so I started a computer club, expected 8 kids. We had 40 people sign up in the first session, and then from Christmas to summer, throughout the school term, we were doing HTML. We had different people. 2 guys there in my school actually do a lot of C programming and C++. We did all these areas, and it wasn't that the interest wasn't there. It just there wasn't any exposure to this. So realistically, there should be no age barrier to it. It's just the exposure that kind of captures this interest and turns it into something.
Excellent. Mark.
How's it going?
Well, so far. Not very controversial, but well. You have yet to enter the workforce. Is that true?
Not actually, because I'm going to be starting internship when I enter 3rd year, but I've actually already started for the company working during the summer. So I think I've been working around a little under 2 months at this stage.
Now, when you look at the academic environment versus the work environment, and you consider the compatibility of a hackspace with either of those, any thoughts?
I think that jumping straight from education to the workforce is a huge jump. I mean, there'd be a lot of people that, I kind of would have worked with in education, and they'd be more, there's kind of an expectation where this is what you have to do.
Speak to them, by the way.
Sorry, okay. So this is what you have to do. Here's the book, you get it. And if you throw together something that isn't half bad, you pass. But, in the workforce, it's completely different. It's really all about self-motivation. It's all about, kind of problem solving. And it's really something that people naturally have if they're, joining a hackerspace. If you're joining the hackerspace, you're not doing it because you have to. You're doing it because, you really enjoy something. You get into it. You're not going to kind of just drop, say, I have a problem, I got an error, that's it, shove the laptop away. You're going to go at it, and really these sort of skills you really need for, the workspace. And I think it's great that people are developing them in hackerspaces, and it's kind of more the person that be geared towards them that is, really just shoots straight into the workplace. They get on great.
Excellent. Martin, my question to you is, do you think it matters where the money comes from to fund a hackspace? And what things would kill a hackspace?
Okay, so firstly about funding, we would prefer, the way that we've run TOG is that TOG is run completely by its members. We had a discussion at the beginning whether we're going to try and go out and look for grants and look for funding, but we didn't want to run that risk because we didn't want to be reliant on that kind of money. At least if money was coming in from its members and people were funding something that they enjoyed and something they loved, then it would thrive. But we didn't want to have a case of we were coming to the end of the year and then the funding that we previously had just wasn't there based on economic climate or a company which was previously sponsoring us doesn't have the money anymore. What was the second part of the question?
Well, I'd like you to elaborate. What is that kind of money?
Money which would be sponsored to the hackerspace, or?
Well, you said we didn't want to take that kind of money. I'm just
sorry.
curious, what kind of money is that kind?
It was that kind of money was mainly likes of applying for grants, like arts grants and things like that.
So government money.
Government money, yeah. There is a few hackerspaces that actually are sponsored by places like Google, and they seem to have that money coming in quite often as well. But we weren't in that kind of a place when we first started to set up TOG. So, and it's something that we haven't felt that we've needed to go after either.
And the second question was, what would you say would destroy a hackspace? What are the dangers?
The dangers of it would be that the hackerspace would go stale, and people would just not be doing anything new. Nothing would attract new members. And yeah, just it going stale, because one thing that we do try and do is we try and have events on within the hackerspace that attract a lot of people and a wide variety of people. At the beginning, a lot of the kind of projects and events that we were running were mainly IT related, so it could be electronics and it could be programming and it could be web design. But now we're doing workshop, like we have a group night on twice a week that do crafts. So we open up the space and people can use the space. People have set up a dark room upstairs now, so people can actually develop film up in the hackerspace as well. So now we're starting to expand outside of just the stereotypical hackerspace, which would be mainly IT and tech, and actually starting to do more kind of hobbies in a more of a craft and photography sense.
So moving right along. What do you think the fears might be in the formal education system if you were to come out and say, hey, let's do Hackspaces all over. Let's do Coder Dojos everywhere. Let's bond these two together. What do you think would come up in formal education?
I think there's one fear in particular in formal education. This is why I said I pitied those guys who just done the Leaving Cert and most people who are in formal education. We do focus the Leaving Cert on points. For example, hands up in the room, those of you who got more than 400 points in your Leaving Cert.
You can raise it really high, come on.
Go on, don't be shy. I'm thinking of the guards in Cork who all get 600. Any Cork guards in the room? Yeah, 10 to get 600 in the Leaving Cert. Hands up those of you in the room who neither know nor care what points you got in the Leaving Cert. Yeah, most employers, frankly, honestly don't care what you got in your Leaving Cert. I think the fear that will crop up most rapidly in the education system is, how do we mark this? At the Leaving Cert is, how do we apportion some of the 600 points of that subject and so on, honours, maths, French, blah, 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 and so on. And in college, the question will be, how many ECTS credits are you going to attach to this? And once you start attaching ECTS credits to it, you start attaching some sort of evaluation. So, how good is your invention? Right? You came up with some great idea, you called it Facebook and it made billions. You come up with some stupid harebrained idea, it didn't make millions. But was your inventiveness not the same? Was your teamwork not the same? You can't measure the outcomes from something like Hackspace quite as readily as you can doing exams by rote. And unfortunately, a lot of what we do in formal education is based on the ability to learn stuff by rote, to reproduce that. And that's how we consider it as measurable in terms of ECTS credit. So I think that for people will set alarm bells. The other thing is you have even more bureaucracy to do with the use of physical space. We're developing something which would fall into the category of Hackspace in the DIT from next September. We got a large room, we're going to throw Wi-Fi and cushions and, in my view, coffee makers and stuff into it. And I think that's as it should be done. And many of us on the academic side of things should never set foot in the room, to be honest with you, unless we're prepared to come in as part of a team and work with Mark and James in developing their idea, not to dictate what they should do, but if we work as peers, it will succeed. If we come in to find out why he's skipping his C programming class, that's not going to work. So I think we'll be afraid that we can't measure it. And
Yep.
I just want to go back to where they were talking about, where it was mentioned about being able to grade people and be able to have like an exam. Just because somebody has a degree in computer engineering doesn't mean they can actually program. It means that they can learn off material and answer a question. If you actually put a question or a task in front of them that's outside of what was done in the labs during the year, majority of people will have a lot of difficulty with it. Where hackerspaces come in is that you have people who want to learn something. People who will go home and they'll spend most evenings and they'll learn a language and they'll learn it very, very well, and they'll actually start doing their own projects. They won't just start doing something just to please the lecturer and just be able to get a piece of paper that says I'm a software engineer. Even from an industry point of view, when you have people coming in, we've had to change the way that we interview people a lot, because just because they have a degree or a master's in a certain topic, it doesn't mean they're not as good as the person who doesn't have a degree, but they've actually been teaching themselves this subject for maybe the last 4 years themselves, or maybe they've been doing it for the last 10 years.
Cool.
Just I'm going to ask a quick answer to the question about how do you evaluate a hackerspace. I'd actually argue that academia has been doing that for years. That's kind of what a PhD is. You're doing something that's never been done before, you hope. Sometimes it'll work, sometimes it doesn't. And academia does have a route to qualify somebody in something they've never done before, whether or not it succeeds. So I could imagine, a similar thing. You spend a year or two in the hackerspace, you spend a while working away, and then you go up in front of a panel who basically say, well, what have you invented? Show us it. Who have you shown it off to? Who has reviewed your work? Are there any other cool hackerspaces where you've shown, traveled to, done demos? What did you learn there? And then, you get your equivalent of a master's or a degree or a PhD based on how amazing your work is. I think it could be done.
Response to that?
I love the idea.
Yeah, I did 2 years of a PhD and dropped out, so I kind of know how it should work.
That's okay. I'm currently trying to finish my third. I didn't finish the first two, so I know what it's like. But I do agree that the notion of a less formal education, however we can bring it about, is to be encouraged. I would much rather walk around Stephen's Green, which is what I do most days at lunchtime, with one or more or several students and colleagues discussing ideas, and come back into the office in the afternoon and put it into practice. I would much rather that than try to lecture a particular technical topic to a room of 20 blank faces who aren't getting it, who to some extent don't care, and for whom the question at the end of the class is this on the exam? If I were to walk into a class and explain to them the workings of a V6 engine or something, I wouldn't be 2 minutes into the discussion, but students would stop me and say, sorry, sir, but is this on the exam? You're supposed to be teaching Cisco networking. Right? There might be relevance to what I'm teaching in a V6 engine, but if it's not directly to the point, and the Leaving Cert is probably more at fault for this because of the way we structure things of formal education. I would love to have a Viva after 3, 4, 5 years in college, whatever it takes, to produce somebody that I know is going to be a good fit for Brian's company or for IBM or for whoever it happens to be. I would love to have a Viva for everybody. And no written exams. Unfortunately, the bureaucracy we have says written exams at Leaving Cert, written exams in college, written exams even with your masters now, with your taught masters courses, and taught elements as part of structured PhDs is getting there as well. So we're moving, unfortunately, the wrong direction from what you're suggesting, which is a Viva. Maybe we should have a Viva for 17-year-olds to decide whether they're suited for engineering. I'd bring it further back than a Viva for 26 or 44-year-olds.
And it's a real shame that when people go out into industry, they don't get a written exam. They get a Viva. It's called a job interview.
So, moving on to a slightly different topic, Mark.
Thank you.
I've noticed that the context in the world is decisive. So if you operate in a certain context, you tend to become part of that mechanism. Stanley Milgram's work putting students into randomly selected prisoner or guard roles very quickly turned average students into sadistic guards and paranoid prisoners because the context was created. Given that you have this ability to play in a hackerspace, and we know from all research that play is a fundamental learning tool, how did you manage to preserve that ability to play so far, going through all the different contexts that you have in your formal education?
I have to actually admit, I don't retain that in college. To be honest, a lot of the material I am, when the students are saying, is this on the exam? If there's actually something that I'm interested in, it's complete flip, but, I don't do it in class, unfortunately. I go out, get a book out of the library, and see if anyone else is interested in the subject, play around that. I'm not really too I'm not really too sure exactly, what causes that. In a sense, it seems to be unsure if it's the lecturers or the students in college. They're kind of saying, which one is kind of pushing it forward or who's actually wants to do it. Because it sounds quite like Mark would actually like to, delve into some of these subjects and kind of teach what people in the hackerspace would like to learn. And I'm going to say something maybe slightly controversial here, but unfortunately, it may actually be down to the sort of students that take the role in the college. To be honest, I was very surprised when I was going to college, the sort of people that were in there. They weren't really kind of techie interested people that, like the majority of them, they were the kind of same people that, the same mindsets that you'd find in secondary school, the kind of, the exams, what to study, kind of just missing out. And maybe if you agree beforehand that, that somewhere in college, that a certain course would be exactly, that would only kind of take on the kind of people that would be in hackerspaces, you might, find that the whole system flips, that, you have a great atmosphere between the students and the lecturers, and, all completely changes. But to be honest, I'm not really too sure where exactly all this originates from, but it'd be something to consider.
James, where did your propensity to play with code come from, do you think?
I was a really, really bored kid. I stumbled across...
Anyone else can relate to being a really, really bored kid? That was excellent. So you're in good company. Keep going.
So basically what happened was I actually started off making animations in Windows Movie Maker when I was like 9, and then I was like, okay, this is pretty cool, I want to put it up on the web. So I saved up my pocket money, and I was pointing in the direction of a book called HTML4 for Dummies. And then I just continued on that, and then once using back in the day of dial-up, I'd kind of search on, and then basically for me, programming, I'd have an idea, and programming was always a means to an end. But as in most certainly, like as I kind of said earlier, with exposure, a lot of people don't know where to start. I was really lucky that my uncle develops a lot of libraries for iOS and the Mac operating system, so he was able to kind of point me in the right direction. But a lot of kids don't have that. Both my parents are dentists. They don't know where they got me from.
And tell me, what was it like when you saw those first kids in the first Coder Dojo taking to it?
It was really, they were perplexed, like they'd never seeing the words "Hello World" on the screen. It was just incredible. And actually, a father who brought his kid along,
yeah, it's working.
A father who brought his kid along, who runs a technology company, actually was able to, for the first time, do HTML with his kid, and they were both writing stuff, and then they dived into JavaScript and CSS, and they were coding together for the first time. And I made sure that I gave them like w3schools.com and a few other resources so that they could go home, they had the basics, and they could continue learning now that they had picked up the whole tag concept.
Excellent. So I'd like to throw open to the audience and see if there are any passionate opinions out there, one way or another, from anything you've heard, or any questions. Down the back, first one, can we run a mic up?
Hi. I have a question probably for Mark, but it probably applies to the others and probably the others in the room too.
Can you say your name first?
Oh, yeah, sorry, my name is William.
And where are you from?
Originally from Australia.
Company?
Company.
Or affiliation? Yeah.
Affiliation, InstallCheck. I've got a startup at the moment with another colleague, but my background really is in science, technology, IT over the last 20 or 30 years.
By the way, the mic works really well if you hold it about a thumb length from your chin.
There.
Yeah.
Great. Hey, you learn something new every day. I've seen quite a lot of people in various companies I've been working through in startups and in hiring. And I found more so in Ireland that I feel that the education system, certainly third level and up, has to some degree been totally devalued by the motivation that people have for taking it up. I'm just curious, from Mark's experience, how many people do you think do any of your courses have any interest or disposition or really even care about the degree they're doing?
Mark, or Mark?
lecturer Mark.
I remember asking a classmate of mine back in the 1980s how come she was doing engineering, and she told me because she didn't get the points for medicine. So it's not a new evolution. Had I not got the points for engineering,